On June 30, 1908, an explosion in remote Siberia flattened roughly 2,000 square kilometers of forest, about the area of Greater London. 80 million trees down, no crater. The blast was heard 800 kilometers away. We still don't know exactly what hit. It was just after 7 in the morning, local time, on a clear summer day. The Tunguska River Basin in central Siberia is one of the least populated places on the planet. Thick taiga forest, some scattered Evenki reindeer herders, a few small frontier settlements along the rivers. A man named Semyon Semyonov was sitting outside a trading post in Vanavara, 60 kilometers from what would become the epicenter. He later described the moment to investigators: a sudden brightness, brighter than the sun, splitting the sky, a flash of heat. He flinched and looked away. A few seconds later, long enough for the sound to travel, a hammer blow knocked him off his porch. The trading post building shuddered, glass shattered. He felt as if his shirt had caught fire. Reindeer herders closer in described being thrown to the ground, tents flattened, whole reindeer herds scattered. Some accounts spoke of a column of fire rising into the sky, 60 kilometers away. None of these people saw what hit. Whatever it was, it never reached the ground. The shockwave was registered on barographs in St. Petersburg, in London, in Washington, D.C., across Europe and Western Russia. The night skies brightened for several days afterward. Newspapers in England reported being able to read at midnight without a lamp. But this was 1908. Tsarist Russia. The Tunguska Basin had no telegraph, no roads, no railway nearby. The First World War was 6 years away. The Russian Revolution was 9. Reports of the event reached the Russian Imperial Geographical Society, but the political crises of the next 2 decades pushed any scientific expedition off the agenda. For 19 years, the largest atmospheric explosion of modern times went unstudied. In 1927, the Soviet Academy of Sciences sent a meteorite specialist named Leonid Kulik to the Tunguska Basin. Kulik expected to find a meteor crater. Specifically, he expected to find an iron-nickel impact site that he could mine. The Soviet Union needed industrial metals. What he found instead was a forest. Kulik's photographs from his 1927 to 1929 expeditions are some of the strangest landscape images of the early 20th century. Tens of millions of trees, lying flat, stripped of bark, all pointing radially outward from a central area. At the center itself, a stand of trees still standing but stripped of all branches, like telegraph poles. No crater, no iron, no nickel, no meteorite fragments of any size that could be linked to the event. Kulik returned in 1928, and again in 1929, and again in 1938. He searched for a decade. He never found an impact site. What he had found was the aftermath of an explosion that had not touched the ground. Modern estimates of the Tunguska event's energy yield range from 10 to 30 megatons of TNT equivalent. For comparison, the bomb dropped on Hiroshima was 15 kilotons. Tunguska was roughly 1,000 times more powerful. The flattened forest covered approximately 2,000 square kilometers, an area comparable in size to Greater London or to Tokyo's 23 special wards. 80 million trees. The fireball was seen from at least 400 kilometers away. The shockwave was felt at 60 kilometers and registered on instruments worldwide. Atmospheric dust raised by the event scattered sunlight for several nights, producing the bright skies observed across Europe and Western Russia. No human deaths have been definitively attributed to the event. The Tunguska Basin's population density was, and remains, extremely low. Modern consensus, supported by computational modeling, is that the Tunguska event was an airburst. A small object, 50 to 80 meters in diameter, entered Earth's atmosphere at a shallow angle and high speed. As it descended, atmospheric pressure ahead of it built faster than the object could shed energy by ablation. At an altitude of 5 to 10 kilometers above the surface, The object failed catastrophically, fragmenting and detonating in a single moment, releasing all of its kinetic energy as a fireball and a shockwave. Because the explosion was atmospheric, no impact crater was produced. The shockwave radiated downward and outward, flattening the forest below. What kind of object was it? That part is still debated. The asteroid hypothesis, supported by trajectory analysis and by microscopic debris searches in regional sediments, points to a small stony or stony iron asteroid. The comet hypothesis, first proposed by F.J. W. Whipple in 1930, points to the lack of any recovered solid material, which would be consistent with a small comet that largely vaporized in the atmosphere. A 2007 study from the University of Bologna proposed that a small, oddly shaped lake near the epicenter, Lake Chico, was a secondary impact crater from a fragment of the original object. A 2008 counter-study, using sediment cores, concluded the lake predates 1908. Researchers continue to publish on Tunguska every few years. The exact identity of the impactor remains an open scientific question. On February 15, 2013, a much smaller airburst occurred over Chelyabinsk Oblast in Russia. The Chelyabinsk meteor was about 20 meters in diameter and detonated at roughly 30 kilometers altitude. Yield approximately 500 kilotons. The lower estimate for Tunguska is roughly 20 times that. The Chelyabinsk shockwave shattered windows across 6 cities. Approximately 1,500 people were injured, almost all by flying glass. The event was recorded by hundreds of dashcam cameras. If Chelyabinsk had been Tunguska, the casualty count would have been catastrophically different. If Tunguska had been over a city, the city would not exist. The Tunguska impactor was never recovered. There are no confirmed fragments. The exact composition, asteroid versus comet, is still argued in the scientific literature. The trajectory has been modeled in multiple ways. The inputs are noisy. Estimates of the size, the mass, the altitude of detonation, and the exact yield all depend on which assumptions go into the modeling, and the error bars are large. What is asterisk not asterisk in dispute? A city-killing event happened in 1908. It happened over a part of the world where there was no city. We have detailed eyewitness testimony from 60 kilometers away. We have photographs of the flattened forest taken 20 years after the fact. We have instrumentation traces from across the globe, and we have no fragment of the object that did it. Tunguska scale impactors are rare but not unprecedented. Astronomers estimate events of this size occur every several hundred to several thousand years. The 2013 Chelyabinsk event, at a fraction of Tunguska's energy, was the largest atmospheric impact of the early 21st century, and it took the asteroid detection community by surprise. NASA Near-Earth Object Survey has improved enormously since 1908. Nearly all kilometer-class asteroids that cross Earth's orbit have been catalogued. Smaller objects, including the Tunguska-size class, are still being detected only sporadically, often days or hours before close approach. The next Tunguska-scale event will happen. It is statistically certain. We are better at watching the sky than we were in 1908. The improvement is real, and it is partial. The most powerful natural explosion of the modern era happened over an empty forest. The next one will not be selected for our convenience.